Most men spend their entire lives using something they never truly understand. I built the first practical electrical distribution system in America, and I can tell you that every time you flip a light switch, you're participating in a system that was designed not for your benefit, but for mine. People believe electricity flows to their homes because of scientific progress and human ingenuity. They think the current system exists because it's the most efficient way to deliver power. They're wrong. What I created was not the best electrical system possible. It was the most profitable system possible. Every wire, every voltage, every connection was calculated to ensure that you would remain dependent, that competitors would be eliminated, and that control would stay concentrated. The technical choices we made weren't about physics. They were about power in its truest sense. Before we continue, take a moment to notice where you're listening from, and if this story stays with you, you're welcome to return tomorrow for what comes next. In the winter of 1876, I established what I called my invention factory in Menlo Park, New Jersey. The newspapers liked that phrase. It sounded modern, scientific, progressive. What they didn't understand was that I wasn't just trying to invent things. I was trying to invent the future, and more importantly, I was trying to own it. My laboratory logbook from those early days tells a story that most historians miss. Yes, we were experimenting with incandescent lighting. Yes, we were solving technical problems. But between the sketches of filaments and notes about vacuum pumps, you'll find something else entirely. Market research, business calculations, studies of how gas lighting companies operated, how they maintained control over entire cities, how they kept competitors out. I had learned something crucial from watching other industries. The man who controls the infrastructure controls everything that depends on it. The railroads understood this. The telegraph companies understood this. But somehow most inventors never grasped it. They thought the cleverness of their device would be enough. They were wrong, and they died poor. Gaslighting fascinated me not because of the chemistry, but because of the business model. Every gas lamp required a connection to the central gas works. Every customer paid monthly bills. Every competitor had to build an entirely parallel infrastructure or go without customers. It was beautiful in its completeness. Gas companies didn't just sell light, they sold dependency. I realized that electricity could work the same way, but better. Gas was dangerous, smelly, limited in how far it could travel from the source. Electricity could be cleaner, safer, more flexible, but only if it remained centralized, only if customers had no choice but to connect to my system. The famous story goes that I tried thousands of materials before finding the right filament for the incandescent bulb. That's true, but incomplete. What I was really doing was designing a complete electrical ecosystem. The bulb was just the bait. The real product was the system that would power it. My team of muckers, as we called ourselves, believed we were changing the world through science. In a way, we were, but I was also teaching them, without saying it directly, that science without business strategy was just expensive entertainment. Every experiment had to serve two masters, technical possibility and market control. I remember the day we finally achieved a practical incandescent bulb that could burn for hours without failing. The men cheered. They thought we had won. But I was already thinking about what came next. A light bulb was useless without electricity to power it. Electricity was useless without a distribution system. A distribution system was useless without exclusive rights to provide it. That's when I began to understand the difference between invention and innovation. Invention was solving a technical problem. Innovation was solving a technical problem in a way that created permanent advantage. The two weren't the same thing at all. We filed patents not just on the successful designs, but on every variation we could imagine. Not because we planned to use them all, but because we planned to prevent others from using them. Patent law, I discovered, was really about creating legal monopolies. The government would enforce our exclusive rights for us. I studied the gas lighting industry like a general studying enemy fortifications. How did they maintain their monopolies? Exclusive municipal contracts, technical standards that favored their equipment, safety regulations written by their own engineers, a web of legal, technical, and political barriers that made competition nearly impossible. The beauty of infrastructure is that once it's built, it becomes almost impossible to replace. Imagine trying to convince a city to rip up all its gas pipes and start over with a competitor's system. The cost alone would be prohibitive. The disruption would be unacceptable. Customers become locked in not by choice, but by the practical impossibility of change. I began to see my electrical system the same way. Every wire we strung, every generator we installed, every customer we connected was creating a kind of gravitational field that would pull in more customers and push out competitors. The larger the system grew, the more attractive it became to new customers, and the more difficult it became for competitors to offer an alternative. My notebooks from 1878 and 1879 reveal the evolution of my thinking. Early entries focus on technical challenges: how to create a stable filament, how to generate sufficient electrical current, how to distribute it safely. But by late 1879, the entries become more strategic: how to price service to maximize dependency, how to design components that would require ongoing maintenance, how to establish technical standards that would favor our equipment. The press called me the Wizard of Menlo Park. They thought my magic was in making light bulbs glow. But my real magic was understanding that the most powerful business model was the one that made itself indispensable. Once customers depended on my electrical service for their basic needs, they would pay almost any price rather than go without. I watched my competitors make the same mistake over and over. They would develop some clever variation on electrical lighting or power. They would demonstrate its superiority in laboratory conditions. They would expect customers to abandon their existing electrical connections and switch over. It never worked. Technical superiority wasn't enough. Customers needed a complete system, not just a better component. This is why I insisted that we develop everything ourselves: generators, wiring, meters, switches, fixtures, bulbs. Not because we could do everything better than specialists, but because controlling every component meant controlling the entire customer experience. It meant that competitors couldn't simply build a better bulb and steal our customers. They would have to build a better everything. The invention factory was really a control factory. We invented solutions that would make customers more dependent, not less. We invented systems that would be difficult to abandon, not easy to improve upon. We invented the future, but we invented it in a way that ensured we would own it. By 1880, I had learned something that most inventors never understand. The goal wasn't to build the best possible technology. The goal was to build technology that would generate the best possible business. Sometimes those aligned. Often they didn't. When they conflicted, business considerations won. This wasn't cynicism. This was realism. The world was full of brilliant inventors who had died in poverty because they had focused on technical perfection while ignoring commercial reality. I was determined not to join them. If that meant making technical compromises to achieve business advantages, so be it. The laboratory logbook ends in 1881 with plans for our first commercial electrical power station. Not just a demonstration, but a real business serving real customers who would pay real money for electrical service. We were no longer just inventors, we were empire builders. In 1885, a man named George Westinghouse changed everything I had carefully built. He didn't mean to be my enemy. He probably saw himself as just another inventor trying to solve technical problems. But when I opened his patent application for an alternating current motor system, I realized I was looking at the end of my electrical empire. The document was elegant in its simplicity. Where my direct current system required power stations every few miles, Westinghouse alternating current could travel hundreds of miles from a single source. Where my system needed thick, expensive copper cables, his could use thinner, cheaper wire. Where my customers were forever tied to local Edison stations, his could be served by distant power plants they might never see. I had spent nearly a decade building a business model based on proximity and dependency. Customers needed to live close to my power stations. They needed to buy equipment designed specifically for my voltage standards. They needed ongoing service that only my trained technicians could provide. Westinghouse's system threatened to make all of that irrelevant. My first instinct was to dismiss alternating current as impractical. The mathematics were more complex. The equipment was less proven. Surely customers would prefer the simplicity and reliability of direct current. But as I studied Westinghouse's patents more carefully, I realized that the technical advantages of AC power were real and significant. This presented me with a choice that would define the rest of my career. I could acknowledge the superiority of AC power and work to adapt my business model to this new reality. Or I could fight to protect what I had built, regardless of the technical merits. I chose to fight. The decision wasn't made in anger or spite. It was a cold business calculation. I'd invested too much in DC infrastructure to abandon it without a battle. My investors expected returns on their capital. My employees depended on their jobs. My reputation was built on the Edison electrical system. Switching to AC would mean admitting that years of work and millions of dollars had been wasted. But more than that, I understood something that Westinghouse didn't. Technical superiority alone doesn't determine market success. Customer perception, political influence, and control of information often matter more than engineering excellence. I had advantages in all these areas that could offset AC's technical benefits, at least for a while. I began what the newspapers would later call the current wars. though they never understood what we were really fighting about. This wasn't a scientific dispute about the relative merits of AC and DC power. This was a business war about who would control the electrical future of America. My first weapon was fear. Direct current, I argued, was safer because it operated at lower voltages. Alternating current was dangerous because it could be transmitted at much higher voltages. This was technically true, though it ignored the fact that AC voltage could be stepped down to safe levels for home use. But technical details were less important than emotional impact. I began arranging public demonstrations of AC current's dangers. Not scientific experiments, but theatrical performances designed to associate alternating current with death and injury in the public mind. I hired Harold Brown, an electrical engineer who shared my concerns about AC power, to lead this campaign. Brown's demonstrations were carefully staged. He would take stray dogs and cats from the pound and electrocute them using alternating current in front of audiences of journalists and city officials. The animals died quickly and obviously. Brown would explain that this was what could happen to humans who came into contact with AC power lines. The demonstrations were gruesome but effective. I knew this was propaganda, not science. The same voltage of direct current would have killed the animals just as quickly. But Westinghouse's AC systems operated at higher voltages, which made the danger seem uniquely tied to his technology. Most audience members didn't understand the technical differences well enough to see through the manipulation. The campaign escalated when New York State decided to replace hanging with a more humane method of execution. They asked electrical engineers to recommend the most efficient way to kill condemned prisoners using electricity. This was an opportunity too valuable to ignore. I instructed my associates to recommend alternating current for the electric chair, not because it was more lethal than direct current, but because I wanted AC power associated with death in the public mind. If the state used AC current to execute criminals, how could it be safe for homes and businesses? Brown worked with state officials to design the first electric chair using Westinghouse AC generators. The first execution was botched. The prisoner didn't die immediately and had to be electrocuted a second time. The newspapers described it as torture. This was exactly what I'd hoped for. Westinghouse understood what I was doing and tried to fight back with his own publicity campaign. He published technical papers explaining why AC power was actually safer than DC for most applications. He arranged demonstrations showing how AC voltage could be controlled and regulated. He pointed out that my own direct current system had caused numerous fires and accidents. But Westinghouse made a crucial mistake. He tried to fight a marketing war with engineering facts. He assumed that rational arguments would prevail over emotional appeals. He underestimated how much fear could influence public opinion, especially when that fear was being amplified by coordinated media coverage. I had learned from studying political campaigns that people don't make decisions based on careful analysis of competing information. They make decisions based on which choice feels safer, more familiar, more trustworthy. My job was to make AC power feel dangerous and DC power feel safe, regardless of the underlying technical realities. The electric chair became the centerpiece of my anti-AC campaign. Every newspaper story about executions reinforced the message that alternating current was the executioner's current. When people thought about AC power, they would think about death. When they thought about DC power, they would think about Thomas Edison and reliable electrical service. This was probably the point where I stopped being primarily an inventor and became primarily a businessman. The decisions I was making weren't about creating better technology. They were about protecting market share and maintaining competitive advantage. I was using fear as a business tool. I told myself I was protecting the public from dangerous technology. I genuinely believed that rapid adoption of untested AC systems could lead to accidents and deaths. But I also knew that my campaign was based more on marketing calculations than safety concerns. The cognitive dissonance was uncomfortable, but not enough to change my strategy. By 1888, the current wars were being fought in newspapers, city councils, and state legislatures across the country. Westinghouse and I weren't just competing for customers. We were competing to define the basic electrical infrastructure that would serve America for generations. The winner would control not just immediate profits, but the technological foundation of the modern world. I had always believed that controlling technology meant controlling the future. Now I was learning that controlling public perception of technology might be even more important. The best system wouldn't necessarily win. The best marketed system would win. This was a lesson that would serve me well and trouble my conscience for the rest of my career. By 1903, I had been fighting the current wars for nearly 2 decades, and I was losing. Westinghouse's alternating current systems were being installed across the country. My direct current infrastructure was becoming isolated islands in an AC ocean. I needed something dramatic, something that would capture public attention and remind people why they should fear alternating current. The opportunity came from an unexpected source. Luna Park on Coney Island owned an elephant named Topsy who had killed 3 men, including a trainer who had fed her a lit cigarette. The park owners decided she was too dangerous to keep and planned to hang her publicly as entertainment. But the American Society for the Prevention of Cruelty to Animals protested that hanging was inhumane for such a large animal. When my associates learned about this situation, they saw exactly what I had been looking for. Here was a chance to demonstrate the deadly power of alternating current in front of a large audience, using an animal that was going to be killed anyway. The park officials were willing to cooperate because electrocution would be faster and more reliable than hanging. I want to be clear about my role in what happened next. I didn't personally travel to Coney Island or directly supervise the elephant's execution, but I approved the plan, provided technical advice, and ensured that my company's film crew would be there to document everything. The decision to electrocute Topsy was mine, even if I didn't pull the switch myself. My team worked with Luna Park officials to design the execution method. We would use Westinghouse AC generators to deliver 6,600 volts through metal sandals attached to Topsy's feet. To ensure she died quickly, we also gave her carrots laced with potassium cyanide. The electricity would be the obvious cause of death, but the poison would guarantee that she wouldn't survive and suffer. The preparation took weeks. We had to calculate the proper voltage and amperage for an animal weighing over 3 tons. We had to design the electrical connections and safety systems to protect the human operators. Most importantly, we had to coordinate with our film crew to capture clear documentation of alternating current's lethal power. On January 4th, 1903, about 1,500 people gathered at Luna Park to watch Topsy die. My film crew set up their cameras to record the execution from multiple angles. The park officials treated it as a public spectacle, selling tickets and concessions. Reporters from major newspapers attended to provide coverage. I watched from a distance as workers led Topsy onto the platform and attached the electrical connections to her feet. She seemed calm, unaware of what was about to happen. When the switch was thrown, 6,600 volts of alternating current surged through her body. She collapsed immediately and died within seconds. The current had killed a 3-ton elephant instantly. The film footage was exactly what I had hoped for. Clear, dramatic evidence of AC power's deadly potential. We distributed copies to newspapers and showed them at public lectures about electrical safety. The images were powerful and disturbing. Here was proof that alternating current was so dangerous it could kill the largest land animal in seconds. But even as we celebrated this publicity victory, I knew something had changed inside me. I had just orchestrated the public execution of an innocent animal for marketing purposes. Yes, Topsy was going to die anyway. Yes, electrocution was probably more humane than hanging, but my motivation had nothing to do with animal welfare and everything to do with damaging a competitor's reputation. The elephant execution marked the moment when I crossed a line I hadn't even realized existed. I had moved from legitimate scientific advocacy to deliberate public manipulation. I was no longer just promoting my technology or even just attacking my competitor's technology. I was using death itself as a marketing tool. The film of Topsy's execution was distributed nationwide. Newspapers ran stories describing how alternating current had killed an elephant in 10 seconds. My associates gave lectures using the footage to demonstrate the unique dangers of AC power. We positioned this as scientific education, but it was really commercial propaganda disguised as public service. Westinghouse tried to counter our elephant campaign by pointing out that the same voltage of direct current would have been equally lethal. He was technically correct, but his rational arguments couldn't compete with the emotional impact of watching a massive animal die instantly from electrical contact. Fear is always more powerful than logic in shaping public opinion. I told myself that I was protecting people from a genuinely dangerous technology. AC power systems did operate at higher voltages than my DC systems. Higher voltage did create greater potential for fatal accidents. These weren't entirely fabricated concerns, but I also knew that AC systems included safety features and voltage regulation that made them no more dangerous than DC for properly trained users. The elephant film became part of a larger media campaign that included newspaper articles, public demonstrations, and political lobbying. We weren't just trying to sell DC power systems. We were trying to create enough fear and certainty about AC power to slow its adoption until we could develop competitive alternatives. What troubled me most wasn't the manipulation itself, but how effective it was. Rational arguments about efficiency and cost were no match for dramatic footage of an elephant dying from electrical contact. People made decisions based on emotion and fear, not careful analysis of technical specifications. This was a lesson that would serve me well in future business ventures, but it also taught me something disturbing about human nature. The success of our propaganda campaign revealed how easily public opinion could be shaped through careful control of information and imagery. Most people didn't understand the technical differences between AC and DC power well enough to evaluate competing claims objectively. They relied on trusted sources to tell them which technology was safer. By positioning myself as the electrical expert and Westinghouse as the reckless promoter of dangerous innovation, I could influence those trust relationships. But I was also learning that propaganda was a double-edged weapon. The same techniques I was using against Westinghouse could eventually be used against me. If public opinion could be manipulated through fear and selective information, then any competitor with sufficient resources and skill could mount a similar campaign. I was teaching the business world lessons that would eventually be turned against my own interests. The elephant execution also revealed something about the relationship between technology and entertainment that would become increasingly important in the 20th century. We had turned a scientific demonstration into a public spectacle. The line between education and entertainment had been deliberately blurred to maximize emotional impact. As I watched the film footage of Topsy's death, I realized I had become something I hadn't intended to be. I was still an inventor, but I was also now a propagandist, a manipulator of public opinion, a man willing to use any means necessary to protect his business interests. The current wars weren't just changing the electrical industry, they were changing me. The most honest thing I can say about the elephant execution is that it worked exactly as intended. Public fear of AC power increased. Sales of DC equipment improved in several markets. Our political allies gained ammunition for their campaigns against AC electrical codes. From a business perspective, it was a clear success. But I never forgot the sight of that massive, innocent animal collapsing from electrical contact that I had arranged. It was a reminder that business success could come at costs that weren't measured in dollars and cents. Some victories changed not just your competitive position, but your fundamental character. I was winning the current wars, but I was losing something else in the process. The telegram arrived on a cold February morning in 1892. J.P. Morgan's office requested my immediate presence for an urgent business meeting. I knew what this meant. My financial backers were losing patience with the current wars, and their patience was the foundation of my entire electrical empire. Morgan didn't waste time with pleasantries. He spread the merger documents across his mahogany desk like a general presenting terms of surrender. Edison General Electric would be merged with Thomson-Houston Electric Company to create a new entity called simply General Electric. My name would disappear from the company I had built. My controlling interest would be diluted to a minority position. I would retain a seat on the board, but effective control would pass to professional managers chosen by the financial syndicate. "Thomas," Morgan said, lighting his cigar with deliberate ceremony, "your war with Westinghouse is costing us money. Thomson-Houston has been gaining market share while you've been fighting yesterday's battles. AC power is the future. We need to embrace it, not fight it." I sat in silence, studying the merger terms that would strip away everything I had built. The numbers were generous. My Edison General Electric stock would be converted to General Electric shares at a favorable ratio. I would retain significant wealth and nominal influence. But I would no longer control the electrical future I had dreamed of creating. The current wars were never about technology, I told Morgan. They were about maintaining independence. Westinghouse wants to control electrical power generation. Thomson-Houston wants to control electrical equipment manufacturing. Together, they'll dominate the entire industry. This merger doesn't solve our competitive problems, it surrenders to them. Morgan's response was delivered with the cold precision of a banker who had made similar speeches to dozens of entrepreneurs before me. Independence is a luxury we can no longer afford. The electrical industry is consolidating. We can be part of a larger, stronger entity, or we can be crushed by our competitors. Those are the only options. I understood what he wasn't saying directly. The financial syndicate had concluded that my strategic vision was flawed. The current wars had been an expensive mistake that had diverted resources from product development and market expansion. While I had been fighting Westinghouse over AC versus DC, Thomson-Houston had been quietly building market share in both technologies. They had positioned themselves as the practical alternative to my ideological rigidity. The merger documents revealed the full scope of my miscalculation. Thomson-Houston had revenues comparable to Edison General Electric, but much higher profit margins. They had avoided expensive public relations campaigns and propaganda efforts. They had focused on engineering excellence and competitive pricing. They had let me and Westinghouse exhaust ourselves in public battles, while they captured customers through superior business execution. Worse, the financial analysis showed that AC power was indeed becoming the industry standard, not because of Westinghouse, victory over me, but because of simple economic reality. AC power was more efficient for long-distance transmission. It required less copper wire and fewer power stations. It could serve larger territories from centralized generation facilities. The technical advantages I had tried to overcome through propaganda and public relations were too significant to ignore indefinitely. I signed the merger agreement because I had no real choice. Morgan controlled the financing that kept Edison General Electric operational. Without his continued support, the company would face bankruptcy within months. I could maintain my pride and lose everything, or accept diminished control and retain substantial wealth. The decision was painful but obvious. The irony was bitter. I had spent years fighting to maintain control over electrical power systems, and I had lost control of my own company in the process. The current wars had weakened Edison General Electric more than they had weakened Westinghouse. By refusing to acknowledge AC Power's technical advantages, I had allowed competitors to position themselves as the reasonable alternatives to both my stubbornness and Westinghouse's innovation. The new General Electric company immediately began transitioning to AC Power systems. They licensed Westinghouse patents and started manufacturing AC generators, transformers, and motors. Within 2 years, they had largely abandoned the DC power systems that I had spent my career developing. My life's work became a footnote in their product catalog. I watched this transition with mixed emotions. As a businessman, I recognized that General Electric's strategy was sound. AC power was technically superior for most applications. Customers wanted it. Competitors were providing it. The company had to adapt or die. But as the inventor who had created the electrical industry, seeing my DC systems abandoned felt like watching my children being disowned. The personal cost was even greater than the business cost. I had built my reputation on being right about technology. The Edison name was synonymous with electrical innovation and reliability. The merger and subsequent transition to AC power made it clear that I had been wrong about the most important technological decision of my career. This wasn't just a business failure. It was an intellectual failure that undermined my entire professional identity. Morgan had been correct about the industry consolidation. Within 5 years, the electrical industry was dominated by 2 large corporations, General Electric and Westinghouse Electric. Smaller companies were either acquired or driven out of business. The competitive landscape I had hoped to control had evolved into a duopoly that I influenced but didn't control. I began to understand that my approach to the current wars had been fundamentally flawed. I had treated them as a technical debate that could be won through superior engineering and effective marketing. But they were really an economic competition that would be won through superior business models and financial resources. Westinghouse had better technology. Thomson-Houston had better business execution. I had better publicity, but publicity wasn't enough. The merger taught me something important about the relationship between innovation and capitalism. Inventors create new possibilities, but financial markets determine which possibilities become realities. I had assumed that creating the electrical industry would give me permanent control over its direction. But capital was more powerful than creativity in determining technological outcomes. My post-merger relationship with General Electric was cordial but limited. I attended board meetings and provided technical consultation, but the major strategic decisions were made by professional managers who had no emotional attachment to DC power or the Edison legacy. They made decisions based on financial analysis and market research, not on founder's vision or inventor's pride. This was probably healthier for the company's long-term prospects. Professional management could adapt to changing market conditions without the ego constraints that had limited my flexibility. They could license competitors' patents without feeling like they were betraying fundamental principles. They could abandon unsuccessful product lines without treating it as personal failure. But it also marked the end of the heroic age of invention, at least in the electrical industry. Technology development would increasingly be managed by committees and corporations rather than individual inventors. Market research would replace personal intuition. Financial planning would supersede technical vision. The future would be designed by bureaucrats, not wizards. I redirected my energy toward other ventures: motion pictures, mining equipment, industrial chemistry. I applied the lessons I had learned from the electrical industry to new fields where individual inventors could still make significant impact. But I never again tried to control an entire industry's technological direction. The current wars had taught me the limits of what even the most successful inventor could accomplish alone. The final irony of my defeat was that it made me wealthy beyond anything I could have achieved through victory. General Electric stock performed exceptionally well as the company benefited from the electrical industry's rapid growth. My financial stake in the merged company generated more income than my controlling interest in Edison General Electric ever had. I had lost the war but won the pension. Looking back, I can see that the merger was inevitable and probably beneficial, but at the time it felt like professional death. I had created the electrical industry, named the major companies, trained the key engineers, and established the fundamental business models. But when the industry matured and consolidated, There was no room for my particular combination of technical innovation and business stubbornness. The future I had created didn't need me anymore. After losing control of General Electric, I found myself with an unexpected opportunity to reflect on what I had actually built. The Pearl Street Station in New York City, my first commercial electrical power plant, continued operating under new management. I would walk past it sometimes, studying the infrastructure I had designed 15 years earlier, and I began to see my creation with different eyes. The original grid map from 1882 tells a story that most people never understood. Every decision about where to place cables, how to route power lines, which buildings to serve first had been calculated not just for technical efficiency but for customer dependency. I had deliberately created a system that would be difficult for competitors to challenge and expensive for customers to abandon. The underground cable network was the foundation of this strategy. Unlike telegraph lines or gas pipes, electrical cables carried dangerous voltages that required careful insulation and professional installation. I had convinced New York City officials that electrical lines should be buried rather than strung overhead for safety reasons. This was partly true, but it was also strategically brilliant. Underground electrical systems cost much more to install than overhead lines, but they created enormous barriers for competitors. Any company that wanted to compete with Edison Electric would need to dig up streets, install their own cable network, and obtain municipal permits for extensive underground construction. The city wasn't going to allow multiple companies to tear up the same streets repeatedly. Whoever got there first would enjoy a natural monopoly. I had studied the gaslighting industry's infrastructure model carefully. Gas companies didn't just sell fuel, they sold access to fuel through networks that customers couldn't practically duplicate. Once a building was connected to the gas grid, switching to a competitor would require completely new pipes, fittings, and equipment. The switching costs were so high that customers rarely considered alternatives. My electrical system worked the same way, but better. Electrical connections were more complex than gas connections. The voltage, current specifications, and equipment standards varied between different electrical companies. A customer who wanted to switch from Edison Electric to a competitor couldn't just change service providers. They would need to replace generators, wiring, fixtures, and control systems throughout their building. This wasn't an accident. I had deliberately designed proprietary components that would work only with Edison electrical systems. Our generators operated at specific voltages. Our wiring used unique gauge specifications. Our fixtures required special bulb designs. Our meters were calibrated for our particular current characteristics. Everything worked together perfectly, but nothing worked with competitors' equipment. The first electrical workers I trained became another layer of customer dependency. Operating electrical systems safely required specialized knowledge that wasn't available in technical schools or trade programs. My company provided the only comprehensive training in electrical installation and maintenance. The workers we trained naturally became advocates for Edison equipment because it was what they understood best. When customers experienced electrical problems, they called Edison-trained electricians. When buildings needed electrical upgrades, they consulted engineers who had learned their trade on Edison systems. When cities wrote electrical safety codes, they asked for advice from experts whose expertise was based on Edison standards. The technical knowledge I had created shaped the entire electrical industry's development. I began to understand that infrastructure creates its own political economy. The companies that build essential systems don't just serve customers, they create constituencies that depend on those systems continuing to operate. Customers become stakeholders in the infrastructure they use. Workers become defenders of the technology they understand. Government officials become protectors of the systems that serve their communities. This was much more powerful than simple customer loyalty. Customers might switch brands if they found better products or lower prices. But they couldn't switch infrastructure without enormous costs and risks. The electrical grid wasn't just a business, it was a piece of the social fabric that people depended on for their daily lives. I had learned this lesson from studying railroad development. Railroad companies didn't just build tracks between cities, they created entire economic ecosystems around their routes. Towns developed at railroad stops, industries located near railroad terminals. Trade patterns emerged that reinforced railroad companies' competitive advantages. Once these economic relationships were established, they became self-sustaining. My electrical infrastructure worked similarly. Businesses located in areas with reliable electrical service. Residential developments emerged around electrical power stations. Manufacturing companies designed their operations around electrical power availability. The more people depended on electrical service, the more valuable electrical infrastructure became. The maintenance requirements I built into the system were particularly important. Unlike gas lamps that customers could repair themselves, Electrical equipment required professional service. Our meters needed regular calibration. Our generators needed periodic overhaul. Our cables needed inspection and replacement. Customers weren't just buying electrical service, they were buying ongoing relationships with electrical service providers. I designed these maintenance requirements to be profitable for Edison Electric, but also to create continuous customer contact. Every service call was an opportunity to sell additional services or equipment upgrades. Every maintenance contract was a barrier that made switching to competitors more complicated. Customers who had invested in long-term service agreements were unlikely to abandon them for uncertain alternatives. The regulatory framework that emerged around electrical service was also shaped by infrastructure requirements. Electrical systems were too dangerous and too important to operate without government oversight. But the technical standards that regulators used were inevitably based on existing systems rather than theoretical alternatives. Edison electric equipment met all the safety codes because we had helped write them. Municipal electrical codes specified wire gauges, voltage limits, installation procedures, and safety equipment that happened to match Edison standards. Not because these were necessarily the best possible standards, but because they were the proven standards. Regulators couldn't approve equipment they didn't understand, and they understood Edison equipment because it was what their technical advisors had experience with. This regulatory capture wasn't achieved through corruption or political manipulation. It emerged naturally from the fact that expertise in electrical systems was concentrated among people who had learned their skills working with Edison equipment. When city governments needed technical advice about electrical safety, they consulted the most knowledgeable engineers available. Those engineers recommended standards based on their professional experience. The result was a self-reinforcing system where existing infrastructure shaped regulatory standards, which shaped market opportunities, which reinforced the advantages of existing infrastructure. Competitors weren't just fighting against Edison Electric's technical capabilities or marketing resources. They were fighting against an entire technological ecosystem that favored established systems over innovative alternatives. I came to understand that this was the real source of my company's power, not just our patents or our technical expertise, but our control over the knowledge, standards, and relationships that defined how electrical systems worked. We didn't just build infrastructure. We built the intellectual and social infrastructure that supported physical infrastructure. This insight helped me understand why the current wars had been so important, and why my defeat had been so complete. Westinghouse hadn't just developed better technology. He had created an alternative technological ecosystem that could support different infrastructure choices. AC power required different engineering knowledge, different safety standards, different maintenance procedures. As AC systems became more common, they created their own constituencies and expertise networks. The transition from DC to AC power wasn't just a technological change. It was a transformation of the entire electrical industry's knowledge base. Engineers had to learn new skills. Workers had to adapt to new equipment. Regulators had to develop new standards. Customers had to accept new risks and opportunities. This was why the change had taken so long, and why it had been so disruptive for companies like Edison Electric that were invested in the old system. But it also suggested something important about the future of technological change. Infrastructure systems become locked in not just because of their physical characteristics, but because of the human systems that develop around them. Knowledge, skills, regulations, and relationships all create resistance to change that can be more powerful than engineering considerations. Looking at my electrical grid map in 1893, I could see both my greatest achievement and my fundamental limitation. I had created a technological system that successfully served millions of customers and generated enormous profits. But I had also created a system that was designed to resist the very innovation and improvement that had made it possible in the first place. The infrastructure trap I had set for my competitors had ultimately trapped me as well. By 1895, I had learned that losing a war could teach you more about power than winning one ever could. While the newspapers focused on the technical rivalry between Edison and Westinghouse, the real battle for control of America's electrical future was being fought in private correspondence between men most people had never heard of. I kept copies of every letter I wrote to utility executives across the country. Reading through them now, I can see the architecture of control that we built together. We weren't just running electrical companies. We were designing the fundamental structure of how electrical power would be governed in America for generations to come. The correspondence with Samuel Insull, who ran my Chicago operations, reveals how systematically we approached market control. Insull understood something that most business leaders missed. Monopoly power wasn't just about eliminating competitors. It was about making competition structurally impossible. We exchanged detailed plans for achieving this goal in every major American city. The key, Insull wrote to me in March 1895, is not to fight for market share, but to shape markets so that sharing becomes impossible. He was describing a strategy that would define American electrical utilities for the next century. Instead of competing with other electrical companies, we would make electrical service a natural monopoly that could support only one provider per territory. The method was elegant and largely invisible to the public. We would work with city governments to establish exclusive franchise agreements that gave our companies sole rights to provide electrical service within specific geographic areas. In exchange, we would accept government regulation of our rates and service standards. This appeared to protect customers from monopoly abuse while actually guaranteeing our monopoly profits. Municipal officials liked this arrangement because it seemed to solve several problems simultaneously. Instead of managing competing electrical companies that might dig up streets repeatedly or engage in destructive price wars, they could work with a single regulated utility that would provide universal service at reasonable rates. The regulatory framework made monopoly appear benevolent rather than exploitative. What city officials didn't understand was that we were writing the regulatory framework ourselves. The electrical codes, safety standards, rate-setting procedures, and service requirements were all developed by committees dominated by our technical experts. We weren't just accepting regulation. We were designing regulation that would protect our market position while appearing to serve the public interest. The correspondence with utility executives in other cities shows how we coordinated these efforts nationally. We shared legal strategies, technical standards, and political approaches across different markets. A regulatory innovation that worked in Chicago would be implemented in Cleveland, Detroit, and Philadelphia. We were creating a national template for electrical monopoly disguised as local public policy. My letter to Charles Coffin at General Electric in 1896 described this strategy explicitly. The goal is not to defeat regulation, but to capture it. Government oversight of electrical utilities is inevitable. Our task is to ensure that oversight serves our interests while appearing to serve the public interest. This requires technical expertise, political influence, and patient cultivation of regulatory relationships. We achieved this through a careful program of personnel exchange between our companies and regulatory agencies. Engineers who worked for Edison Electric or General Electric would eventually take positions with state public utility commissions. Regulatory officials who proved cooperative would be offered lucrative consulting contracts with electrical companies. The revolving door between industry and government wasn't accidental. It was strategic. The technical complexity of electrical systems gave us enormous advantages in these relationships. Utility commissioners couldn't evaluate rate requests or safety standards without technical expertise, and that expertise was concentrated among people who had worked for electrical companies. When commissioners needed advice about whether proposed rates were reasonable, they consulted engineers whose careers had been built on maximizing electrical company profits. This wasn't corruption in the traditional sense. The engineers and executives who moved between industry and government were honest professionals who believed they were serving the public interest. But their understanding of the public interest had been shaped by years of working within electrical company cultures that prioritized system reliability and financial sustainability above competitive innovation or consumer choice. My correspondence with J.P. Morgan's financial syndicate reveals another layer of control that operated above the level of individual utility companies. The same financial institutions that had forced my merger with Thomson Houston were coordinating electrical industry development across the entire country. They weren't just investing in electrical companies, they were planning electrical infrastructure as a national asset that would generate predictable returns on capital. Morgan's approach to electrical utilities was based on his experience with railroad development. Both industries required enormous capital investments that could be recovered only through decades of reliable revenue streams. Competition was inefficient and potentially destructive for capital-intensive infrastructure businesses. Coordination and consolidation were necessary to protect investor interests and ensure stable service. Financial Syndicate established informal agreements about which companies would develop electrical service in which territories. This wasn't formal collusion that could be prosecuted under antitrust law. It was strategic coordination that prevented wasteful competition while maximizing returns for all participants. Utility companies would focus on operational efficiency within their assigned territories rather than fighting for market share across territorial boundaries. These territorial agreements were enforced through financial control rather than legal contracts. The same investment banks that funded electrical utility development also controlled access to capital markets for expansion or equipment purchases. A utility company that violated territorial boundaries would find itself unable to raise money for necessary infrastructure improvements. Financial discipline was more effective than legal constraints for maintaining market order. The result was a national electrical industry that appeared competitive but was actually highly coordinated. Dozens of separate utility companies served different geographic markets, but they all operated according to similar business models, technical standards, and regulatory relationships. Innovation occurred within narrow parameters that didn't threaten the fundamental structure of utility monopolies. I began to see this coordination as a form of invisible government that operated parallel to official political institutions. Electrical utilities made decisions about which areas would receive reliable power, which industrial customers would get favorable rates, and how quickly new communities would be connected to electrical grids. These decisions shaped economic development patterns across the entire country, but they were made by private companies according to business criteria rather than democratic processes. The correspondence also reveals how we managed political relationships to maintain this system. Utility companies were major employers in most communities, significant purchasers of local goods and services, and important sources of tax revenue. This economic influence translated into political influence that protected utility interests, even when those interests conflicted with broader public concerns. We cultivated relationships with political leaders through campaign contributions, consulting contracts, and business partnerships. Not bribery, but legitimate business relationships that created mutual dependence between utility companies and political officials. A mayor who supported favorable utility regulations might find his brother-in-law hired for a good job with the local electrical company. A governor who appointed cooperative utility commissioners might receive substantial campaign support in the next election. The most sophisticated aspect of this political strategy was its emphasis on technical rather than political justifications for utility policies. When utility companies requested rate increases or opposed new regulations, they presented detailed engineering studies and financial analyses to support their positions. Political officials rarely had the technical expertise to evaluate these arguments independently, so they had to trust utility companies' claims about operational necessities and cost requirements. This technical complexity made utility regulation appear scientific rather than political. Rate-setting procedures were based on mathematical formulas that calculated fair returns on investment. Service standards were derived from engineering studies of system reliability requirements. Safety regulations were developed through technical committees dominated by utility engineers. The entire regulatory framework was presented as objective administration of technical requirements rather than political choices about economic priorities. By 1900, this system of controlled competition and captured regulation had become the standard model for electrical utility development throughout the United States. The apparent diversity of utility companies masked underlying uniformity in business practices, regulatory relationships, and political influence. We had achieved through coordination what we couldn't achieve through direct consolidation, effective control over America's electrical infrastructure development. Looking back at this correspondence, I can see that we succeeded beyond our wildest expectations. The utility industry structure we designed in the 1890s remained essentially unchanged for nearly a century. Electrical utilities became the most stable and profitable investments in American capital markets. Customers received reliable service at reasonable rates. Government officials could claim credit for protecting the public interest through utility regulation. But we also created a system that was inherently resistant to innovation and democratic accountability. The electrical industry became a technical bureaucracy that served financial markets more faithfully than it served electrical customers or broader social needs. This was the price of the stability and profitability we had achieved. We had solved the problem of destructive competition by eliminating meaningful competition altogether. In 1925, as I watched workmen install the first electrical meters equipped with remote reading capabilities, I realized that my control mechanisms had not only survived the transition to AC power, but had evolved into something more sophisticated than I had ever imagined. The patent chain that connected these new meters to my original designs revealed how business models can outlive the technologies that created them. The modern electrical meter patent documentation tells a fascinating story. Each improvement built upon previous innovations, creating a legal and technical lineage that traced back to my first Pearl Street station. While the underlying technology had changed from DC to AC, from mechanical to electromagnetic, the fundamental business relationship between utility and customer had remained exactly as I had designed it. These new meters didn't just measure electrical consumption. They were designed to gather information about customer usage patterns, peak demand periods, and system loading characteristics. The data would help utility companies optimize their operations, but it would also give them unprecedented insight into customer behavior. I began to understand that information could be more valuable than electricity itself. The remote reading capability was particularly ingenious. Instead of requiring monthly visits from meter readers, the new systems could transmit usage data back to utility offices through the electrical lines themselves. This reduced operational costs for utility companies while increasing their control over customer relationships. Customers would receive more detailed bills, but they would also be subject to more sophisticated monitoring. What struck me most was how little this fundamental relationship had changed since my original Edison electric system. Customers still had no practical alternative to utility-provided electrical service. They still used equipment designed to utility specifications. They still paid monthly bills for a service they couldn't store, produce independently, or purchase from competitors. The dependency I had created in the 1880s had become the foundation of a modern industrial economy. The utility monopoly structure I had helped establish had not only survived, but had become more entrenched over time. The territorial exclusivity agreements we had negotiated with municipal governments had evolved into state-regulated monopolies backed by public utility commissions. What had begun as private business arrangements had become permanent features of American economic law. I studied the rate-setting procedures that had emerged from our early regulatory experiments. The mathematical formulas were more sophisticated, but the basic principle remained unchanged. Utility companies were guaranteed reasonable returns on their invested capital, regardless of operational efficiency or customer satisfaction. This removed competitive pressure while providing steady profits that attracted conservative investors. The technical standards that we had established for electrical equipment had become national codes that effectively required all electrical devices to conform to utility-compatible specifications. A customer who wanted to generate their own electrical power faced regulatory barriers, technical incompatibilities, and economic obstacles that made utility dependency the only practical option. The system was self-reinforcing in ways I had never anticipated, but I was also beginning to see signs that this control structure might be vulnerable to the same kinds of technological disruption that had made my DC system obsolete. Small-scale electrical generation was becoming more efficient and affordable. Battery storage technology was improving. Some customers were experimenting with independent electrical systems that could operate separately from utility grids. The utility industry's response to these developments reminded me uncomfortably of my own reaction to Westinghouse's AC innovations. Instead of embracing technological improvements that could benefit customers, utility companies were using regulatory and legal mechanisms to protect their existing business models. They were fighting distributed generation with the same fear-based arguments I had used against AC power. I watched utility executives lobby state legislatures to restrict customer-owned electrical generation. They argued that widespread adoption of independent electrical systems would undermine grid reliability and increase costs for remaining customers. These were plausible concerns, but they were also convenient justifications for protecting utility monopolies against competitive threats. The parallels to my own anti-AC campaign were striking. Utility companies were emphasizing the dangers and limitations of new technologies while downplaying their potential benefits. They were using technical complexity to confuse policy discussions. They were mobilizing political influence to maintain regulatory barriers against competitive alternatives. The playbook I had written in the 1890s was still being used in the 1920s. This pattern suggested something troubling about the relationship between technological innovation and established business interests. Industries that achieved dominance through superior technology often became obstacles to further technological advancement. The same strategic advantages that enabled initial success could become sources of resistance to subsequent innovation. My electrical utility empire had been built on the principle that centralized generation and distribution was more efficient than distributed alternatives. This was true in the 1880s, when electrical generation required large, expensive equipment that individual customers couldn't afford to own and operate. But technological progress was making smaller-scale generation increasingly practical and economical. The utility industry's regulatory advantages were preventing customers from benefiting from these technological improvements. Rate structures that subsidized large industrial customers while penalizing small residential users discouraged energy efficiency and distributed generation. Interconnection requirements that made customer-owned generation expensive and complicated protected utility revenues while limiting customer choices. I began to see that the regulatory capture we had achieved in the 1890s had created a form of technological stagnation that was harmful to continued innovation. Utility companies had guaranteed profits regardless of efficiency, so they had little incentive to develop better technologies or business models. Customers had no alternatives, so they had no leverage to demand improvements. The smart meter patents revealed another layer of control that was emerging from technological capability rather than regulatory protection. The same electrical lines that delivered power to customers could also carry information back to utility companies. This created possibilities. for real-time monitoring and dynamic pricing that would give utilities much more sophisticated control over customer behavior, I could envision a future where utility companies would know exactly when customers used electrical appliances, how much power each device consumed, and what daily routines created peak demand. This information could be used to optimize electrical system operations, but it could also be used to manipulate customer behavior through pricing incentives and service restrictions. The potential for abuse was enormous. Utility companies could penalize customers whose usage patterns didn't align with operational preferences. They could charge premium prices during periods when customers had no choice but to use electrical power. They could use consumption data to make decisions about creditworthiness, insurance rates, or employment eligibility. But the most disturbing aspect was how invisible this control would be to customers. Unlike the obvious dependency created by physical electrical connections, information-based control could operate through subtle pricing signals and service adjustments that customers might not even recognize as manipulation. The utility monopoly was evolving from crude physical control to sophisticated behavioral influence. I realized that my original electrical system had created a template for technological control that was being applied to other industries and technologies. Telephone companies, railroad companies, and manufacturing corporations were all using variations of the utility model to achieve market dominance through infrastructure control and regulatory capture. The success of this approach was encouraging other industries to adopt similar strategies. Instead of competing through superior products or services, companies were trying to establish control over essential infrastructure that would make customer dependency inevitable. Innovation was being redirected from customer benefit toward competitive advantage. This transformation worried me more than my personal defeat in the current wars. The electrical industry I had helped create was becoming a model for economic organization that prioritized control over innovation, stability over improvement, and investor returns over customer welfare. This wasn't what I had intended when I set out to electrify America. Looking at the patent chain that connected 1920s smart meters to my 1880s electrical systems, I could see both the power and the danger of technological legacy effects. Business models and control mechanisms could persist long after the technologies that created them had become obsolete. Successful innovations could become barriers to future innovation by creating vested interests in maintaining existing arrangements. The utility industry had become too successful for its own good. The monopoly profits and regulatory protection that had enabled rapid electrical infrastructure development were now preventing the continued innovation that customers needed and deserved. My creation had become a constraint on the very technological progress that had made it possible, but I also saw hope in the growing tension between technological capability and institutional resistance. Customer demand for energy independence was increasing. New technologies were making distributed generation more practical. Political pressure was building for regulatory reform that would allow more competition in electrical markets. The same forces that had made AC power inevitable despite my resistance were now making distributed generation and competitive electrical markets inevitable despite utility resistance. Technological progress couldn't be stopped permanently by regulatory barriers or business model protection. Eventually, customer needs and technological possibilities would overcome institutional obstacles. The question was whether the electrical industry would adapt to these changes willingly or would fight them until forced to change by external pressure. I hoped that current utility executives would be wiser than I had been in the 1890s, but I suspected they would make the same mistakes I had made. The temptation to protect existing advantages rather than embrace uncertain innovations was too strong for most business leaders to resist. My legacy in the electrical industry was more complex than I had expected. I had created not just a technology or a business, but a model for how essential technologies could be controlled and monetized. This model had enabled remarkable infrastructure development and economic growth, but it had also created barriers to continued innovation and customer empowerment that were becoming increasingly problematic as technologies continued to evolve. In October 1931, a few months before my death, I made my final entry in the laboratory notebook that had accompanied me through 50 years of invention and discovery. The handwriting was shakier than it had been in my youth, but my mind was clearer about the relationship between technology and power than it had ever been during the height of my career. I wrote, "The greatest invention is not a device or a process, but a way of thinking about the relationship between human needs and human control. I created electrical systems that served people's needs, but I also created systems that served my need to maintain control over people. The two purposes were never the same, though I spent decades pretending they were. This wasn't the kind of technical notation that had filled thousands of previous pages. This was an attempt to understand what I had actually accomplished, and what it meant for the generations who would inherit the electrical world I had helped design. The notebook had become a confession as much as a record of discovery. Looking back across my career, I could see three distinct phases in my relationship with electrical technology. First, the pure invention period when I was solving technical problems without fully understanding their commercial implications. Second, the business building period when I was learning to monetize innovation through strategic control. Third, the reflection period when I was trying to understand the broader consequences of my choices. The first phase had been intellectually exciting but commercially naive. I had believed that superior technology would automatically generate superior returns and social benefits. I had assumed that customers would recognize and reward innovation, that competitors would respect technical excellence, and that markets would efficiently allocate resources toward the most beneficial innovations. These assumptions were wrong, but they had motivated some of my most important discoveries. The second phase had been financially successful but morally complicated. I had learned that commercial success required strategic thinking beyond pure technical innovation. I had developed skills in patent law, political influence, marketing manipulation, and competitive warfare that were as important as engineering expertise. I had achieved market dominance and personal wealth, but I had also created systems designed more for control than for customer benefit. The third phase had been personally troubling but intellectually honest. I had begun to understand that my business success had come at costs that weren't reflected in financial statements or technical specifications. I had created technological dependency that limited customer freedom. I had established monopoly structures that restricted innovation. I had used fear and misinformation to defeat superior technologies that threatened my commercial interests. The tragedy wasn't that I had failed, but that I had succeeded too well. The electrical infrastructure systems I had designed were serving millions of customers reliably and profitably. The business models I had created were generating steady returns for investors. The regulatory frameworks I had helped establish were maintaining stable monopolies that avoided destructive competition. By most measures, my career had been a remarkable success, but I had also learned something disturbing about the relationship between innovation and control. The same strategic thinking that enabled rapid technological development could also become an obstacle to continued innovation. The same business models that rewarded initial invention could become barriers to subsequent improvement. Success in one technological generation could become the foundation for resistance to future technological change. This was the current truth that I had spent decades avoiding. Electrical technology had the potential to liberate people from physical drudgery, geographic limitations, and economic constraints. But the way electrical technology was developed and deployed could also create new forms of dependency, control, and limitation that might be more subtle but equally constraining. I had chosen control over liberation, not because I opposed human freedom, but because I believed that control was necessary to achieve the technical and financial success that would ultimately benefit everyone. I had told myself that monopoly profits would fund continued innovation, that infrastructure control would ensure reliable service, and that customer dependency would create stable markets that could support long-term technological development. These justifications weren't entirely false, but they weren't entirely true either. Monopoly profits had funded some continued innovation, but they had also reduced competitive pressure for improvement. Infrastructure control had ensured reliable service, but it had also prevented customers from developing alternative solutions. Customer dependency had created stable markets, but it had also eliminated customer choice and reduced customer power. The electrical industry that emerged from my work was a mixed achievement. It had accomplished the technical goal of providing reliable electrical service to millions of people. It had accomplished the economic goal of generating substantial profits for investors and employment for workers. It had accomplished the social goal of enabling new forms of economic activity and personal convenience that improved living standards for most customers. But it had also created a model for technological development that prioritized business control over customer empowerment, financial returns over social benefits, and system stability over continued innovation. This model was being applied to other technologies and industries, creating an economic structure that served capital more faithfully than it served human needs. I began to understand that technology was not politically neutral. The specific ways that technologies were developed, deployed, and controlled reflected the values and priorities of the people and institutions that controlled technological development. My electrical systems embodied my own values, the importance of business, success, the necessity of competitive advantage, and the desirability of maintaining control over important resources. But they also embodied values that I hadn't consciously chosen. The assumption that customers should be dependent rather than independent, that centralized control was preferable to distributed autonomy, and that business interests should take precedence over customer interests when the two conflicted. These values had been implicit in my technical choices, but they had shaped the electrical industry as powerfully as my explicit technical decisions. This suggested something important about the responsibility that inventors and business leaders bear for the long-term consequences of their work. We don't just create technologies. We create technological systems that embody particular assumptions about how human societies should be organized. These assumptions become embedded in infrastructure that can persist for generations, influencing social and economic relationships long after the original creators are gone. I had not intended to create a model for technological control that would be applied to other industries. I had been focused on solving immediate technical and business challenges in electrical power generation and distribution, but the strategic approaches I had developed were being used by telephone companies, automobile manufacturers, chemical companies, and other industries to achieve similar forms of market dominance through infrastructure control. The pattern was becoming clear across multiple industries. Companies that achieved early technological leadership would use patent protection, regulatory capture, and infrastructure dependency to maintain competitive advantages that had little to do with continued technological superiority. Innovation would be redirected from customer benefit toward competitive protection. Technological progress would slow as successful companies focused on preserving their market positions rather than developing better solutions. This wasn't an inevitable consequence of technological development, but it was a predictable consequence of the business models and regulatory frameworks that had emerged around technological innovation. Different approaches to patent law, regulatory structure, and competitive policy could encourage different relationships between technological capability and market control. I had learned too late that the most important inventions were not technical devices, but social and economic institutions that determined how technical devices would be developed and used. The patent system, the regulatory framework, and the business models that govern technological innovation were more influential than any particular technical breakthrough. If I could have approached my career differently, I would have focused more attention on these institutional innovations and their long-term consequences. I would have tried to create business models that aligned commercial success with continued innovation rather than with market protection. I would have tried to design regulatory frameworks that encourage competition and customer choice rather than monopoly stability. But I also understood that individual inventors and business leaders have limited ability to shape these larger institutional patterns. The competitive pressures and financial requirements that drove my own strategic choices were not unique to me or to the electrical industry. They were systemic features of an economic system that rewarded short-term competitive advantage over long-term social benefit. The hope I could offer to future generations was that technological capability itself was creating new possibilities for more democratic and decentralized approaches to innovation and economic organization. The same technological progress that had enabled my centralized electrical systems was now making distributed alternatives more practical and affordable. The current truth was that technology could serve human freedom or human control, depending on how it was developed and deployed. The electrical systems I had created had demonstrated both possibilities. They had liberated people from some limitations while creating new dependencies. They had solved some problems while creating others. They had served some interests while subordinating others. The choice between liberation and control was not a technical choice, but a political choice that would be made by each generation according to their values and priorities. My generation had chosen control because we believed it was necessary for achieving technological progress and economic prosperity. Future generations might choose differently if they valued customer autonomy and democratic participation more highly than system efficiency and business profitability. The electrical infrastructure I had helped create would eventually be replaced by newer technologies and different business models, but the institutional patterns and social relationships I had established might persist much longer. The greatest responsibility of technological innovators was not just to solve technical problems, but to consider carefully what kinds of human relationships and social structures their solutions would encourage or discourage. I could not undo the choices I had made, but I could offer this final reflection to anyone who might learn from my experience. The most powerful technologies are those that increase human capacity for freedom, creativity, and mutual support, rather than those that increase capacity for control, dependency, and domination. The current truth is that we always have this choice, even when competitive pressures and financial incentives seem to dictate otherwise.